go. Thunderwear.
That was a really funny joke. I liked it a lot. Welcome back, scientists. We have been learning about all sorts of crazy weather phenomenon. But how does it all go together? I thought we should learn how it goes together. Let's learn how it goes together in something amazing called the water cycle. All right, cool factoid. The water cycle is how water moves continuously on Earth. It is also called the hydrologic or hydrological cycle. Now, the water cycle means that water comes down, water goes up, water comes back down again. Let's do an experiment today to understand this better. What did the lightning bolt say to the lightning bolt? Ready for it? You're shocking! All right, friends, there are 3 stages. There's a few more, but 3 primary stages of the water cycle that we need to learn about today. The first one is precipitation, right there. And that is water coming down. Then is condensation, and that is the water coming together. And then we have evaporation, and then that's the water going back up. And that is tied together with flow. So we're going to talk about these 3 primary stages and flow. And then we're going to do a really cool experiment. Ready? Let's go. Let's learn something really cool. So first on our agenda is evaporation. Evaporation, say it with me, evaporation is exposed water, like oceans, rivers, lakes, your sweat, your dog's sweat, and plant transpiration. So this exposed water gets heated up by the sun and it turns into water vapor or gas. And then it rises. Where does it rise? Can you see me thinking? What do you think evaporates faster? Cold water or warm water? Next important stage is condensation. Condensation is clouds or the forming of clouds. So when the water vapor rises in a gas form, it goes up into the upper atmosphere. And that's that sort of invisible bubble around our Earth. It then hits the cold air. And when the vapor hits the cold air, it changes into liquid. These liquid droplets then hang on dust particles in our atmosphere and they form clouds. Sometimes the nice white fluffy clouds we see, or the stretched out clouds, or those heavy dark thunderheads. But they're all formed by water vapor that has risen into the upper atmosphere through evaporation and then it condenses into clouds. Joke time. What kind of clouds are super lazy? Give up? Fog. Yeah, fog's clouds. Cool. Then we have precipitation or precipitation. It depends who you ask at my house. So we have precipitation. That is when the water droplets collide up in the atmosphere. And as they collide, they crash, they go up, down, left, right, and eventually they condense together and they grow larger and heavier. And also what's up there is something called updraft speed. So suddenly when fall speed is greater than updraft speed, those large water droplets that have condensed together are too heavy and they start to fall. And they fall in 4 primary ways. They fall through rain, sleet, which is icy rain, snow, or hail. How cool is that? So the water evaporates, it condenses, and then rain falls in the form of precipitation called rain, sleet, snow, or hail. That was really cool. So we have evaporation, condensation, and precipitation. Now, how does that look? Well, okay, Well, we also have float, but I'm going to tell you that in a minute. So we have our lake or our river, and the water evaporates because the sun comes out and it heats everything up. So as the water evaporates, it comes up into the atmosphere and it condenses into clouds. And then as the water vapor collides into droplets and becomes heavy, it then falls back down to earth in the form of precipitation. And then there's something called flow. So as the water comes down, it falls into rivers, lakes, or oceans. It also soaks into the ground, and that becomes groundwater, which feeds the plants. And as it rains, animals and humans also consume the water. And then the water goes right back up again when the sun comes out and we sweat, or animals sweat, or plants transpire, or the water just evaporates out of the bodies of water like lakes and oceans. And that's the cycle. It happens over and over and over again. So back to my question. What do you think evaporates faster, cold water or warm water? And how does evaporation work? I feel like we should kind of conduct an experiment to understand that. Well, actually, I'm going to conduct half the experiment, and then you guys are going to conduct the other half of the experiment. And then think about it with your brains. So for today's experiment, we are going to need some materials. We're going to need water, food coloring, 2 plastic bags, tape, a sunny window, a Sharpie or some Sharpies, a grown-up, and a plastic water bottle for part 2, because after this experiment, if you wanted to try this experiment inside a plastic water bottle and set it outside, you could do that. That's your part 2. Let's go gather our materials. Do you guys have your materials? I have all my materials. Now, you're going to need to take a minute and draw a picture on both of your Ziploc bags. Relatively the same picture. I'm going to show you what I drew. All right, so here we have our water cycle. We have our sun. We have our clouds that represent condensation. We have our cloud that will represent precipitation and rain. There is our rain. And then over here we have an ocean or a sea. We have some groundwater and some ground and a tree. And we have a lake over here. And then we have all sorts of areas of evaporation. And remember, we talked about that trees transpire and the water they release goes into the atmosphere as evaporation. Lakes and oceans and streams evaporate as evaporation and vapor. So we have to include all those things. So go draw both of these water cycle examples onto your Ziploc bag and then get ready to do some experimenting. Questions that go with our experiment today. Ready? I'm going to read them kind of slow so you can think about them. So, number 1, what noticeable differences do you observe? What are you going to see as our experiment happens? Number 2, did you observe the water cycle? Did you observe evaporation, condensation, and precipitation? And number 3, the longer the bags hang in the sun, will you observe the water cycle repeat itself? Because remember, the water cycle means it goes continuously on and on. As the water evaporates, it condenses, then rain comes down in precipitation, and then again it evaporates, condenses, comes down in precipitation. Will you be able to observe that today? All right, scientists, so you have 2 bags. On both your bags, you should have drawn your diagram of your water cycle. And in bag 1, we're going to need a little bit of a grown-up's help because we're going to boil some water. And then we're going to take 1/2 cup of the water that we have boiled and we are going to pour it into the bag with 1 drop of food coloring. Then you are going to seal your bag really well, hang it in a sunny spot, and observe what happens. In bag 2, where you've also drawn your diagram, you are going to also add 1/2 cup of water. But in this one, you're going to add cold water and 1 drop of food coloring, seal your bag, hang it in the same place, and observe. And I'd like you to make yourself a chart where you can document your observations and see how long it takes for the water cycle to happen and for it to repeat itself. And does the water cycle start to happen almost immediately in bag 1 or 2, or does it take time? These are all things that I'd like you to take into consideration today. All right, so I have my chart and I have my 2 bags. And notice in my chart, it's simple. I just put bag 1 and bag 2 and the time where I'm going to pour in my water and start to observe. And then I'm going to write down my observation, and I'm going to maybe draw a picture of what I observe. And then maybe I'll come back in 5 minutes or 10 minutes or 30 minutes or an hour. You get to decide that. I am going to come back in 15 minutes and make another observation. And I will continue doing this until I feel like I understand the water cycle and when I actually see the water cycle happening, because it should happen. All right, because this experiment is really for you guys to do some exploration and figuring out, I'm just going to give you a really quick demonstration of what you need to do, and then I'm going to have you guys try it and see what happens. But let's see, we're going to try my room temperature water. It's not cold, it's not hot, it's room temperature. That means it's lukewarm. It's the same temperature as the room I'm in, and I kind of like my room warm, so it's kind of tepid. So here we go. So we're going to take 1/2 cup of water and pour it in my bag. Whoa, do you see it? How cool is that? And then I'm going to add 1 drop of food coloring into my bag. Go, go, go. It's stubborn. All right, and then I'm going to add a little bit more water to make sure my food coloring goes down. There we go. Okay. All right, now, oh, look how cool. My water's so cool. I'm going to seal it up really well. Make sure it's tight. I'm going to mush my water around a little bit. And now I'm going to observe and see what happens. Now, I have to go put my bag in a sunny place for my experiment to be successful, because remember, evaporation needs heat, which in our case is usually provided by sunlight. Although I wonder if the boiling water might have something to do with the process of evaporation. But anyway, okay, so I have my Ziploc bag of water. I have my diagram. It's hanging, and I'm going to go put it in a sunny window, and I'll check back in with you later. How do hurricanes see? What do you think? With 1 eye. Get it? Eye of a hurricane. I thought it was funny. So, during your experiment, you're boiling some water with your grown-up. I wonder if you see any evidence of evaporation there. Perhaps some learning might happen during the process of setting up your experiment. Are your bags in the sun? Is water evaporating? Are you observing the water cycle? I hope so. Some really cool water fun facts. Did you know that water covers 70% of the Earth's surface? That's a lot of water. Water makes up about 60% of the human body. That means about 60% of your body is made of water. Whoa! And did you know that the only substance that appears on Earth naturally in all three physical states of matter, remember, liquid, gas, solid, are water, ice, and vapor? Which one is a gas? Vapor. Which one is a liquid? Water. And which one is a solid? Oh yeah, ice. How neat. Hi, scientists. So I hope your experiment has been successfully accomplished and observed and documented. And if not, I hope you have a chance to go do that. And if you have already accomplished it, or if you're going to do it in a little bit, and think about some questions for after, they're right here. Things to think about. Number 1, after your experiment, can you describe the relationship between the water cycle and life on Earth? How does the water affect humans? How does the water cycle affect animals? And number 2, how does snow fit into the water cycle? Snow? Well, it is a solid form of water. How does that fit into the water cycle? 2 questions. Think about them. Let me know what you think. Scientists, we had an awesome day today. We've been learning about rain, snow, wind, and we tied it all together with the water cycle. And I hope you've conducted your experiment, and I hope you observed some really interesting things, some really cool weather phenomenon. Well, and I really hope you did a lot of thinking today. Well, I can't wait to see you next time. Have an amazing scientific day, and catch you later. Bye.
What did one raindrop say to the other raindrop? My blob is bigger than your blob.